Right now, AI document search has a major blind spot. If you ask a system for a company's 2023 profit, it might return a paragraph about 2023 revenue growth. Why? Because most AI search relies on finding text that looks similar to your prompt, but semantic similarity isn't the same thing as factual correctness. Look at the standard architecture used today, known as Retrieval Augmented Generation, or RAG. It takes your query, converts the words into a mathematical embedding, searches a vast vector database for matches, and spits out a result. But to make those databases work, systems use a process called chunking. They slice complex documents, like 50-page financial reports, into arbitrary 500-word blocks. The context gets destroyed. A table header lands in one chunk, the data in another, and the AI loses the logical thread entirely. Think about how a human expert reads a textbook. They don't take a pair of scissors, chop the book into hundreds of random paragraphs, and try to match the words to find an answer. Instead, a human looks at the table of contents. They understand the structure, navigate to the relevant chapter, find the exact page, and pull out the specific data they need. This brings us to a framework designed to replicate that exact process. It's called PageIndex. It is a vectorless, reasoning-based RAG system that abandons artificial chunking entirely, relying instead on a document's inherent structure. To achieve true accuracy, we have to stop treating documents like a soup of disconnected words. We have to teach AI to actively reason through structural hierarchies. PageIndex replaces vector chunks with a tree structure. When you upload a document, the system generates a highly intelligent table of contents. Every section becomes a tree node, preserving context with a title, summary, and page range. You upload a file, the system maps the tree, and a large language model reasons over it, reviewing summaries to find exactly where the answer lives. Once the model identifies the correct section, it retrieves only the raw text from that localized node to construct a precise response. When the AI encounters an incomplete section or a reference to another part of the text, it can fetch those neighboring pages or subnodes. By building context iteratively instead of guessing through a fragmented chunk, the system anchors its answers in the document's actual continuity. During active retrieval, the AI traverses this tree structure using a step-by-step thinking process. It reads the root nodes first, evaluating the high-level sections before making a choice. It then dives deeper into the subnodes. Just as a person runs their finger down a physical index, the AI outputs its internal logic as code, documenting exactly why it chose a specific path before it extracts any data. This pure reasoning approach is incredibly accurate, but there is a trade-off. Running a full language model at every decision point gets slow when you apply it to massive, highly complex documents. To fix this scaling issue, PageIndex uses hybrid tree search. It runs the deep LLM reasoning and a faster, value-based vector scoring process simultaneously. Both feed into a central queue. An intelligent controller monitors the results and halts the search the moment it hits an accuracy threshold. This hybrid approach bridges the gap between raw machine efficiency and careful human deduction. Developers can implement this through a standard Python or JavaScript SDK. You simply upload your file to the PageIndex cloud, check the processing status, retrieve the generated tree, and start sending queries. There is also a built-in chat API. It handles real-time streaming, tracks multi-turn conversations, and provides inline citations so you can audit exactly which page generated every part of the answer. But for advanced architectures, PageIndex uses the Model Context Protocol, or MCP. This allows custom frameworks like LangChain or OpenAI agents to hook directly into the PageIndex index. This enables agentic retrieval. Through MCP, an AI can autonomously use tools to investigate the document structure and fetch page content on its own, without waiting for explicit human prompts. This integration grants the model agency. It explores the structure, calls its own tools, and builds a comprehensive answer through its own investigation. When scaling to thousands of documents, you can use multi-doc search strategies. This involves using SQL queries to filter structured metadata or calculating a semantic doc score to rank the most relevant files before the deep tree search even begins. And if you are dealing with visual data, the framework supports vision-based RAG. It passes document images directly into a vision language model, skipping optical character recognition entirely. In high-risk environments like legal contract review or financial analysis, these methods matter. On the rigorous finance bench testing standard, PageIndex hits an accuracy rate of 98.7%. The future of AI retrieval relies on combining clear document structure with dynamic reasoning. We have tools to let AI read and understand text the way a human would, instead of forcing it to blindly search like a machine.